In this video, we will go through a Monte Carlo problem. The example that we will go through is a net present value example with nonlinear growth rates. A Monte Carlo introduces randomness into the problem, whereas a discrete would use many exact numbers. The Monte Carlo makes more sense for net present value when looking towards the future because values may be expected, but that does not necessarily mean that those will be the exact values that actually occur.
Principles in constructing the problem. We can use randomness in our demand because this variable can be estimated but will never be a constant. With a set NPV problem with varying demand, we can see our likely or expected NPV for each year. In our problem, the software that we just used a random function built into Excel. In other cases or other examples, maybe using MATLAB or Simio could be more helpful and easier to use. And there's other functions also we can use in MATLAB and Simio more than Excel.
This problem seems very accurate because of its adaptability. So for the real world, it seems to make sense because if you know a range for your demand and the cost of production, this problem will suit real world problems quite well. Using the following variables, we were able to run 50 iterations of this experiment. The demand formula uses the function rand multiplied by a constant to give it a random number centered around 10. Then for the rest of the net present value numbers, we were just able to use different Excel functions to calculate this.
To interpret the results for this problem, we looked at the mean and upper and lower confidence intervals. The mean value is $11,836.55. A standard deviation value as well as upper and lower confidence intervals are shown. And the team focused on ensuring that our confidence interval was not negative, so the majority of our values would give us a positive net present value. This is applicable for use because businesses could use this to simulate demand and net present value without needing the data.